Welcome everyone to our first big OMC Open Market Consultation major event of the POWERBASE project. My name is Regine Gerhards. I'm from THW. I'm happy to represent the THW team. We are one of the emergency response organizations in this project, and also we coordinate this project. So I'm just I would like to welcome all guests, especially the companies that followed our invitation today. We have so many pitch presentations on technical solutions today, so it's really great to see that you are curious about our project and our needs and our approach, and we are happy to welcome everyone. Also, we have some external guests from other fields, from a diverse field of interests, either in the field of emergency response organizations, everyone related to emergency shelter or basis of operations, from the energy sector, from research. We have representatives of the European Commission here. So a very warm welcome to everyone as well. Yeah, and also we have some participants at the virtual space. Yeah, hello there. Glad you could join. And finally, also we have the POWERBASE consortium, of course, and the advisory board members. Yeah, good to see you, everyone. So POWERBASE was initiated in 2023. And since then, we gained more and more attraction and attention, and could improve our outreach and our impact. And so it's really great. We had so many valuable discussions already about our needs and about our ambitions. So today we would like to follow up on this, continue discussions with the market. And before I start, I would just quickly like to thank the partners who mainly were involved in the organization of this event, which is the colleagues from Arctic and the colleagues from Kimea. And then, of course, a big thank goes to the European Commission that makes this happen by funding the project, this event, everything, the air we breathe, you know. Thank you. We are so grateful that we can conduct this project. Yeah, then next, I would just quickly go through the agenda and everything we would like to do today. My notes, Jim. So, and also maybe organizational wise, just for you to know, the Wi-Fi password is on the little signs at the side. Something else, yeah, we will have a few presentations soon, and I kindly ask you to save your questions for the Q&A session we have. I'm pretty sure there will be many questions because there will be a lot of input, but yeah, we will have space and also breaks to solve everything. Yeah, so first I will give a brief introduction on the POWERBASE project. Marijn will present the objectives and the idea of the open market consultation. Eleni will then go a bit into detail on the pre-commercial procurement process, and Björn will present the state of the art, the results of our state of the art analysis so far. We will then have presented the scenarios and needs by Jakob and Sandra, and yeah, then the already mentioned Q&A session. After a coffee break, we will then hear from the suppliers their pitches they prepared, and have a break in between. And then after, there is the opportunity to go into dialogue. You all, with the forum, I think, agreed or disagreed on being open for discussions also with other suppliers. So there will be a fancy drink, I heard, and some snacks for this. And yeah, we finished the event at about 6 o'clock. For the internal partners, maybe just a brief information for the consortium that we will have dinner, I think at 7:30, I think, yeah. All right, then I just start with the brief introduction on the POWERBASE project. Key facts: we are 12 partners from 10 countries. Among these partners, we have 8 emergency response organizations, so there is a very high practitioner focus. And we started in October 2024 with a project time, and it finished in September. We receive about 1 million euros of funding from the European Commission for that. This is the list of our partners. We have emergency response organizations on the left side in a different broad field of experience and relief they support, technical relief, of course, and firefighters. We have organizations with focus on medical and humanitarian support and ministries of the interior. Further, we have 2 research institutes with high experience that support the project, and then we have 2 consultancies for legal advice and advice in regards of project management and communication. And yeah, just a quick heads up on our vision. This visualization is very detailed. We don't have to go into this that detail, but you may have a look at it later. It comes also up during other presentations. What is most important to know is that we are in phase 0 of a prospective innovation procurement process. We receive funding basically to discuss between practitioners what is our need. We believe that there is a common need for low-emission energy solutions for emergency shelters and bases of operations. At the same time, we look at the market. We look for answers and solutions that might solve our problems. If there are no ready solutions, we will prove if it's possible to develop a solution with further funding. So the further funding phases are the phases 1, 2, 3 that you see in this graphic. And yeah, Eleni will later go more into detail of the procurement process. So let's see what's next. The objectives, our objectives, just as a brief summary. Also, our main aims are: first, describe unmet needs for renewable energy supply in future relevant emergency response scenarios. Also, we would like to develop, or we are developing, a holistic state-of-the-art analysis of commercially available renewable energy solutions and emerging technologies. We are further accelerating innovation uptake by strengthening public procurers on innovation procurement, which is a big issue for public administration in any field, and also in emergency response, of course. And then finally, also we are fostering the cross-sectoral stakeholder engagement on end-user needs and renewable energy solutions. We have conducted a lot of workshops and meetings and activities and already achieved certain milestones. We started with a scenario definition. Jakob will go more into detail on that soon. And following by the needs assessment through workshops, as I mentioned, and surveys that are still ongoing to assess our needs as open as possible. In parallel, there was already running the state-of-the-art analysis, and we now started the procurement preparation. And of course, you all heard about this project, so the stakeholder engagement, dissemination, exploitation is an ongoing task through the whole project. Finally, we are, as I said, very happy that many solution providers followed the invitation today. We have a broad experience here, and will be very curious and excited about your presentations in this different fields of technologies, energy storage solutions, power supply solutions, and transport solutions soon. And this is it from my side, and I would like to hand over to Marijn.
Hello, everyone. My name is Marijn van Jaarsveld. I have written to a lot of you, and today I'm going to tell you about the objectives of our open market consultation. So open market consultation basically is a structured dialogue between public buyers, end users, and the market. And it's a very important step in preparing for innovation procurement. The aim is to collect input from suppliers, from researchers and innovators, and this will help us prepare for a future procurement process. How does the POWERBASE open market consultation look like? It started in February 2025 when we published a prior information notice on tenders Electronics Daily. You may have seen it. It was relatively brief, just outlining the procedure of our open market consultation, and it also described very briefly the objectives of the project. This was followed by a more extensive OMC scope document that you should all have received. And this contained information about the project itself, for sure its objectives, but also the first requirements. So those are preliminary requirements that we put out there for the market to provide input on. So this was an important preparation step for this event. We also published online, you may have seen it, a Q&A document with answers to questions. And if you have further questions, feel free to ask them. We will put answers also online. An important possibility for you, the market, to provide input to our open market consultation is through technology showcases. And the project will organize 4. The first one took place in March during the Ceres event, and I'm not sure if Instagrid is present at the moment, but they were there as well. So that was sort of really free companies presenting to an audience of emergency response organizations. So today we will have our second technology showcase. And we just want to point out to you that there will be further technology showcases. So I know that there are some suppliers in this room who did not prepare a presentation. Please note that there are further opportunities to present your technology. Further on, we have a request for information questionnaire. Many of you filled it out. Thank you very much. This is really a wealth of information for us to do our open market consultation. For the ones that did not fill it out yet, so it is the QR code. So if you did not fill out the request for information questionnaire, please make sure to fill it out. You find a QR code, although I have to say that the survey works best on a desktop computer. So please fill it out. So all the information we will collect today, our OMC event is our most important event, but also the following events we will discuss during an OMC workshop, which will take place on August 28 and August 29 in Athens. And we will have also a webinar on lessons learned, and all findings will be combined in an OMC report. Why do we do these things? So the purpose of this open market consultation is to collect feedback from the market if suppliers are able to satisfy the unmet needs. And this is a very important input for us to assess whether POWERBASE will proceed with innovation procurement. So why do we need an open market consultation? So the importance of an open market consultation is for us to assess what the market capabilities are and whether they meet our expectations. We want to make sure that we aren't overlooking novel or unconventional solutions, so this is why you are here. And very importantly, we want to promote innovation. So if there's an innovation gap, we are considering follow-up funding, and this will stimulate innovation and also competition. And this is a very good opportunity. I know some of you are SMEs. You may not respond to a very large public tender, but it may be an opportunity for you to benefit from funding to stimulate innovation. So why should you take part? What are the benefits for you? So first of all, you will get early insights into procurement plans, and you will be able to understand the technical, operational, and environmental requirements before the tenders are published. This will be a very good source of information. Further, you can showcase your capabilities. So I've asked, or we've asked many of you to prepare a presentation, and we've provided you today also some requirements, and we've asked you in your presentations to address these capabilities. We are very curious to hear about that. Further, this is an opportunity for you to build partnerships. It may be possible that you are able to address one part of the requirements, but you find a partner who is able to address other parts of the requirements. And for that, we have our matchmaking session. So, this is a very good opportunity for you to promote your visibility and take part in partnerships. So how does our open market consultation work? We present our preliminary state-of-the-art analysis, our needs and expectations in presentation from my colleagues, and then we invite you during our Q&A session to react. So you can provide feedback, you can showcase relevant solutions during the presentations later on, and you can flag some trends. So to get back to the timeline, as said, we have our request for information questionnaire, so if you did not fill it out, please fill it out. But we also want to point out that we have some further technology showcases. And there's one, it is a showcase together with the IFAFRI, the International Forum to Advance First Responder Innovation. And there's a QR code here. It will be, there's an US time too, because as I said, there are also some US companies joining, and you may be able to, as I said, promote your company to a wider audience there as well. And we have our OMC workshop, which will take place end of August, and you are also welcome to join either in Athens or online. So in case you did not showcase your technology yet and you want to do that, please use the QR code to sign up. So this is it. I thank you very much, and I hand over to my colleague, Eleni.
Thank you, Marianne. Hello, everyone. I'm Eleni Ilianou. I'm a member of the team of the Center for Security Studies, KEMEA. And my presentation, before of course diving into the most exciting part that my colleagues will present you, the state of the art, our needs and expectations, and of course the technical requirements. My presentation will, with my presentation, I will briefly introduce you to the pre-commercial procurement. Of course, most of the aspects will be legal aspects, but in case you have any question, we are here to discuss it, and of course we can provide further information and clarifications. So, our POWERBASE project, as my colleague Regina already mentioned to you, is a CSA project. It's a coordination and support action, being actually a preparatory action in order to build the grounds for a future pre-commercial procurement, an action that is actually oriented to the acquisition of R&D services. And of course, I will explain in the next slides what we mean by that. During this project, the POWERBASE project, the CSA POWERBASE project, there will be actually no procurement. What we are doing now is, of course, during this open market consultation process, to collect feedback, to identify our needs and expectations, and of course, to choose and to define a list of requirements in order to be better prepared for a future procurement. So, during the open market consultation, and of course during the whole duration of our project, we need to actually reply to one major question: whether there is an available solution to the market. So, if there is, so we need to go with the traditional procurement and of course buy the solutions that already exist. But if not, we can opt for innovation procurement. And in order to choose what kind of innovation procurement we will launch, we need to reply to the question whether there is actually an innovation gap, whether actually R&D is needed. If R&D is needed, we have to go with a pre-commercial procurement. If not, a PPI, a public procurement of innovative solutions, is an option. Just a definition, I think everyone always likes definitions. Of course, this definition comes from the directive of 2014, the procurement directives. And when we say innovation, actually it's the implementation of a new or significantly improved product, service, or process. And this is, of course, in order, with a purpose always, to help to solve societal challenges or to support the Europe 2020 strategy for smart, sustainable, and inclusive growth. On the other hand, what is innovation procurement? Innovation procurement actually is a methodology, is a tool that has been already set by the Commission back in 2007, and with Commission Information Notice of 2021, innovation procurement has actually taken shape, meaning that innovation procurement actually refers to any procurement that has one or both of the following aspects: or buying the process of innovation, this is R&D actually, with partial or not outcomes, or buying the outcomes of innovation. And of course, I will explain here in this slide what we mean by buying the process of innovation, actually buying R&D services. In this case, we have a PCP, and in this case, the public buyer, the group of public buyers, actually are buying their R&D services of products, services, and processes which do not exist in the market. So throughout the duration of the PCP, R&D is required, and R&D should be actually developed. And the public buyer actually describes the needs, as we are doing now in the open market consultation, prompting businesses and researchers to develop innovative products, services, or processes in order actually to address our need. On the other hand, when we say buying the outcomes of innovation, we mean that, of course, the public buyer or the group of public buyers, instead of buying off the shelf, acts as an early adopter, as the first customer, and buys a product that is new to the market but contains substantially novel characteristics. So, two main aspects of the pre-commercial procurement. R&D is needed to identify an innovative solution to satisfy our needs and our expectations, and solutions do not exist yet in the market, solutions that actually meet all our needs and all our expectations, based, of course, on the continuous research process. And when we say a continuous process, is of course the dialogue with the market, the open market consultation, the conduction of surveys, the definition of the state of the art, etc. Here in this graph, you can have a very, let's say, brief, but I think accurate, view of what a PCP is. It's a process of 4 phases, actually, starting from phase zero, when we have curiosity-driven research, is what we are actually doing now. before launching any call. And then the PCP will continue with phase 1, 2, and 3. In phase 1, what is expected from suppliers is actually to design the solution, and then during the coming phases, the prototype development and the original development of first series of products is needed. Important to note that PCP is actually a procurement of R&D. It's a competitive development between phases. It's a risk-benefit sharing at market conditions, and there is a clear separation between the R&D and from the deployment of commercial volumes of end products. And this is the reason why in the last part, phase 4, where we have a PPI, it's actually a totally different procurement. The advantages of the PCP. As you may see here, there are lot of advantages, either for the public sector or for the market, and of course for the whole society. First of all, for the public sector, for us actually, it's important because what we are looking for and the reason why we're using a PCP is in order to improve the quality and of course the efficiency of public services. It allows us to obtain better quality products for lower prices because it's a competitive process. And of course, it reduces risk of failure in a follow-up PPI procurement. For the market, as you may see there, it accelerates the access to the market, maybe to a scientific actually oriented market, shortens time to the market for innovative products and services, facilitates the access of new innovative players to the market, and of course, stimulates company growth and attract private investment. And for the whole society, we always looking for better use of public resources. With a PCP can help tackling environmental and social challenges, and of course creates high added value jobs for Europe. Before closing my presentation, I would like just to give you an idea on a very specific topic of the pre-commercial procurement, which is of course very important for you to know, because actually it's one of the aspects that are more, let's say, interesting and challenging for the suppliers. And the reason is why it's because although it's a procurement, IPRs, the ownership actually of the results, the foreground results, the results that are going to be developed during the PCP will remain to the supplier that has actually developed the results. This means that, of course, you need to declare any pre-existing rights in order to define any dependencies. But of course, you as suppliers, you have the obligation to protect the results, to commercially exploit the results, and we as buyers, we can help you. We need to help you. We have to help you to promote R&D. So, in case we decide as a POWERBASE consortium to go with a PCP, and we will launch a call for tenders, any contractor that may enter to this procurement, while developing results, will keep the ownership of the results. And it will give access for free, of course, to the buyers just for internal use. And this is, of course, a very important aspect for the innovation uptake and, of course, for the commercial exploitation of the results. This being said, actually, I finished with my presentation. I really thank you for your attention, and I give the floor to Jakob. I think, no, to Bjorn, yeah, thank you.
Yes, so I'm Björn Hoog from the Fraunhofer INT, the Fraunhofer Institute for Technical Trend Analysis, and I will present you the results and also in general the state-of-the-art analysis in the context of the POWERBASE project. So at first, what is a state-of-art analysis? Also in the context of best practices, also called prior art analysis. So the main objective is actually to look at what technologies do we actually already have on the market, or innovation processes, how do they perform, what advantages they have, what disadvantages, what characteristics, and also what how good their performance is with regards to measures. Also, of course, it's important what stakeholders are involved in the on the supplier side and on the innovation side. So also is the market concentrated or the development concentrated in Asia or in Europe or so on, and this is the basic purpose to give a point of reference also for later orientation in further steps in POWERBASE, but also in general in such type of projects. So as already said, it's also to identify quantitative metrics and also emerging trends, so things that could change on the market, but also in research that have to be considered. This information that you get out of this state-of-the-art analysis should serve as decision support for different stakeholders afterwards. So also potentially for suppliers, how they could couple with other suppliers, and of course it's also a form of trying to benchmark different technologies. So our methodology was that we that of course the first step is narrowing down the technologies that you can analyze. So we really focused on technologies that were relevant for energy supply or electricity supply, for emergency response organizations, for bases of operations and emergency shelters. And we, as procurement and innovation process, can also take some time. We were also considering technologies that could be ready by 2035. So how did we do that? We had a systematic four-pillar plan. So we had inputs about technologies from the users, so emergency response practitioners. We also looked at recent R&D projects from the EU, but also from other funding funding pots and so on. And also we look in general at scientific literature and market reviews, so market trends regarding specific technologies. And also there was the possibility to always contact us with some information that people believe to be relevant in our context. And what we are currently also doing is a patent analysis and bibliometric analysis. So basically we are analyzing big data sets of scientific sources. So the result was that we developed technology fact sheets. So these are as the name already suggests, brief summaries about the description of certain technologies with regards to POWERBASE and how they function and what current market and development trends are, and what the implications or what considerations are relevant in the context of POWERBASE. We developed two types of technology fact sheets. So for the more relevant technology, we did large technology fact sheets with about 10 pages, and mini technology fact sheets that were like 2 paragraphs for less relevant technologies that that are relevant in general for the energy transition, but less for our context. I mean, we'll talk later about the requirements in more detail. So there are some examples about the technology. So we looked at classical photovoltaics, but also at thin film photovoltaics, at wind energy generally, at hydrogen. Also, we looked at more, like, as I already mentioned, less relevant technologies for us, but we still considered it in our mini technology fact sheet, like nuclear power and microreactors, and also, for example, wave power energy. But in total, we analyzed 36 different technologies. With also, this can be further elaborated in different subtypes, so you could see as even more. So yeah, and of course, we also looked at lithium-ion batteries and also at redox flow batteries. But as I mentioned, these are just examples of this type of technologies. Yeah, we put these technologies into different categories, just for orientation. So we had this category energy harvesting or direct electricity generation. So a classic example is photovoltaic cells. Then we had also the other category, energy conversion. So if you have, for example, a chemical fuel that is an energy storage type, that of course then afterwards you would need another technology to convert this chemical energy into electric energy. And the last one was, of course, energy storage, so batteries, capacitors. We also covered mechanical systems, and of course, the most common storage system, chemical storage. So in the end, as I already said, we developed different technology fact sheets. Right now, we are working on summarizing them, going from 10 pages for each technology description to 3 or 4. You can find the current version with the really detailed information in the deliverable, that if you can scan the QR code over there. So this is just a screenshot on the right. So, and what was the conclusion so far? So in general, we saw there were a lot of commercial off-the-shelf solutions already that have to be considered, and that are quite mature and can contribute to a system that would be suitable for POWERBASE. But these are only the different technology components. So it was really hard to find suitable options that are already integrated systems that cover conversion, energy, and generation in one system with the right size. So we had complete systems that are already on the market, but they were usually container-sized or on a trailer, or stationary systems are really small for camping, for example. So this was something that we realized when we visited trade first, but also looking in general at the market. And it seems so far that we have some really specific demands for the market and for innovation, with regards to the requirements, and I think we will talk about it later in a moment. As the leader of the state-of-the-art analysis, what we need from you suppliers and innovators is that we would like from you further hints about relevant technologies that you find that are important in the context of emergency response missions, and also, of course, to inform us about your technologies and how your technology performs. What are the characteristics and clarify how they work. And also, as mentioned already earlier, it would be really suitable if you're already thinking about how your technology component can be matched with maybe some other technology to build such a comprehensive mobile energy supply system for the specific purpose in POWERBASE. Yeah, that's it from my side. Then I would hand over to Jakob to link to the different operational scenarios we were talking about.
Thank you very much, Björn. Okay, so then Sandra, you can put it lower because I'm aiming high with the microphone, that's for your information. Thank you very much. So my name is Jakub. I'm from Samaritan, Slovakia. In my daily life, I'm head of operation of 2 EU CPM modules, which is MEDEVAC, flight evacuation module, and emergency temporary shelters, where we accommodate up to 350 people. So just very shortly. So I'm coming from we call it emergency response organizations, and we are part of the project to bring our needs, to bring our thoughts, and what and how we operate, how we can be even efficient and with a low emission. So at the very beginning of the project, we had to discuss how we will start it, where to start. So we need to define the scenarios. So, but the scenario in Slovakia, in Austria, in Sweden, or in which country? But then in the end we found out, but we operate worldwide. So we need to have a solution or future device to be able to operate worldwide, not only in our small sand spot. So we decided to define 3 main scenarios, which is the forest fires in Corsica in France. Then we had the flood in the Central Europe, in Czech Republic, and then we had the Himalayas earthquakes. So we decided that those 3 scenarios are for us the main, how we will test the future device, how it could be basically the best way to put it to the extreme situation and challenges for the rescue teams to use and to have this future device on board. So basically, my colleagues before already showed you this picture. So this is how we're aiming. So with all holistic approach, we are trying to find the best way for us as an emergency response organization to work with this future device. Then, to go a little bit more deeper, we decided to have for each main scenarios 2 sub-scenarios. So basically, we are aiming for the emergency shelter, and also we are aiming for the base of operation. For those who are not familiar with those terms, the emergency shelter means that we are accommodating the evacuees or the people who are in need and they lost the houses and flats. For the base of operation is basically how we as an emergency response organization are operating and living. So command center and let's say our base where we live, and before our shift we sleep. So basically those all aspects we are trying to aim and look at it in every main scenarios. This is where it all started. So we, as my colleague Regine, she said, we are all different experts from different organizations, from different countries, sitting together and giving all our thoughts and needs, and we are trying to prepare at this phase 0 to be in the future very successful project, because in the end of the day we will be end users of this product. And of course we are trying to aim it that it will be not only the product for the end user, but it will be the product for also the private sector, so for the different organization and association and stuff. So when we started, we briefly had the scenarios overviews. We sit and we discuss it from different point of view. So we started about geographical context and overview. So where it could be, should be waterproof, should be dustproof, should be that. So we all put it together to each scenario that fits not only for those 3 scenarios, but it fits also for different countries, for different emergency scenarios and crisis situations. Of course, very important for us as a medical personnel are also health and safety risks. So we were discussing how it could be involving the future device, how we can put those risks and our assessment to be even better prepared and use this device. And of course, infrastructure. We are aiming for 2-3 weeks of crisis. We are at the project not aiming for the long 2-3 years solution. So in that, it has to be very deployable, very quick. We have to use it very quick. We have to take it and move from the place to place to work with it. And of course, it is not only international, but also for the local and national emergencies in our countries. We know that the situation in the world is changing and we have even more and more crises. So we have to be ready for the natural disasters everywhere in the world, and not only natural. So the first scenario is wildfire on a Mediterranean island. So we decided to use the Corsica as a nice example. So what is happening very often every year in the world? So we have extreme drought, we have high temperatures, strong winds, and that all together is doing something like that. So we use AI generated pictures just to show briefly how it can looks like. So consequences to these scenarios are that we need, the fire is rapid spreading, so we have to be very efficient, very quick. And of course, it's causing the threat to the population and the infrastructure, including the fauna and flora. So we have to be really also thinking about it. So definitely in such a huge emergency, there is also the national capacities are overwhelmed. So they calling for the international rescue teams and modules. So, and when we are coming, we have some challenges. For example, in that scenario, we all different experts sit together and we said, okay, we need to establish base of operations somewhere. So it is safe to be near or quite away. So we have to be ready to evacuate in case of emergency for us. Then we have to, of course, we have displaced people. It could be in the summer, okay, perfect. A lot of tourists are coming to Corsica, so we have to think about that we have also different nations in this scenario. And of course, the future device has to operate in extreme heat and humid conditions. So this is just to show you how we thought, how we can build then the requirements, and how we were even deeply discussing how it should looks like for the future, that we can use it in that case of scenarios. So we have now the winter floods in the Central Europe. As I mentioned, we decided to use as an example Ostrava in Czech Republic. We have those floods everywhere in the Europe nowadays, especially when they are hit after the snow melting. So we have a lot of snow, then we have a lot of floods, and then we can have even the landslides. So we have to consider also that. So sudden warning and rainfalls are happening even during the winter time. So basically what the consequences I mentioned a little bit. So what we are aiming to as a challenges for the rescue teams is establishing again a base of operation in extreme winter condition, even the -degrees. Even it could be very wet surroundings, so we have to take that as to consider. And of course, providing aid to evacuees. So it could be, that few kilometers away we have enough grid, but at the on-site where we have to operate and evacuate people, we have to be really careful. And then we go to the last one, which is earthquake in Himalayas. So the earthquakes are really nowadays happening even more and more, and we have to take that to consider as well. So we decided to use as national park Langtang in Nepal as an example. For example, we as a showcase decided to use a 7.9 magnitude earthquake, which, as you know, is really devastating earthquake for the infrastructure, buildings, mountains, roads, and everything. So in that scenario, as a consequence, we are going and to be deployed to the situation that there are over 50,000 casualties. 35,000 injured people and 1.2 million displaced people. And we have to, as a response organization and rescue teams, to deal with the situation. So what are the challenges for us in that type of scenario? Of course, the roads are destroyed and we have to go up to the mountains. So we have less oxygen there. So our future device has to take that also, how it will be able to operate at a high altitude. Then of course we have unpredictable weather. So perhaps we have during the day extremely hot, but during the night it could be freezing. So rapid changes. Of course we have a monsoon season approaching, so it could be also very wet. And as I mentioned, even within first scenario, so due to landslides, we have to be able and very mobile and flexible to evacuate ourselves and even people. So we have to be really mobile with this device. Thank you very much. And I'm giving word to my dear colleague, Sandra.
Thank you, Jakub. Good afternoon, all here in the room and also online. My name is Sandra Nestling. I'm working for the Austrian Red Cross in the Department for National Disaster Management and Research, and also for Union Civil Protection Mechanism. I would like to link in the now brought down to needs and requirements presentation, also to a presentation given yesterday by the Commission. Philip is present today, who also mentioned that capabilities are really important in this topic of funding. And I think Eleni mentioned also before that capabilities of the market have to be represented in the project. And Philip also referred to end users, emergency response organizations, not only being a tick box in proposals and in projects, giving the big representative audience of responders in this project, we do show that it is not only a tick box, that we collect a lot of requirements and that we show our really deep interest in innovation uptake. But now to the most important aspects for you as potential suppliers or suppliers on the market about the requirements. We are still in the charging process of requirements. You saw it's an ongoing thing from the very beginning until the end of the project, and it refers to the way of harvesting and generating, like Björn mentioned before, and conversion, but also the storage of energy. And as Jakub already mentioned, there are a lot of aspects to be taken into account for the scenarios. Scenario building is a basic aspect for emergency response organizations for being prepared and to operate in the response quickly, fast, and effective. And Jakub already mentioned that we have to have stored energy to do immediate response, to offer immediate support for those affected. And we do have challenges in logistics, like you saw in the Himalaya scenario. But of course, we also have to scale up and be mobile if we have to move when there are landslides or the wildfires expanding. We also need, of course, kind of women and manpower to carry stuff. It's also related to logistics, so we cannot carry trucks if there are no roads. We have to be mobile carrying with persons. And training is an aspect not only for operating with tools, but also for health and safety, like Jakub mentioned before. Networking with other tools and having support by suppliers is a big aspect in our needs assessment, and also the maintenance, because we think ahead of, we are not going to buy something, we will operate with it, there might be some maintenance, and of course we have to think about the whole life cycle we use the tool for. And as you know, when we buy things, when we procure things, when we purchase things, it's always also part of the whole process and structure to think about the money and financial aspects and the affordability. Currently, we are operating, most of us, with like fossil fuels, and this project aims to go ahead for sustainability and more low-emission power supply. And still we want to be able to connect it with existing technologies, because we cannot just replace all of them at once. And to refer back to the scenarios, when we think of needs, we don't think about existing solutions, or at least we try to. We try to think about really what we need when we are out there in the field, in a camp like you can see in this picture, or when we are out there and building up the camp, because we don't only need energy to provide light for the camp, but we also want to heat it. We might be in need in heat waves to cool it. We do have medical aspects involved for refrigerators for medication. And we also think about of the modularity, like sketches like MSP supported with for camps, or the Ministry of Interior in France. And you can also see that there are examples for light and power generation, even providing heating in these pictures. And the mobility giving nowadays with trucks and lorries to carry it and to install it on site. Why are those requirements needed? You already heard it in the very nice presentation on PCP and OMC by Eleni and Marijn, because it's one of the base stones to get ahead for the full track of a PCP, or even for choosing one of the already existing tools. We're in phase 0, and we can only select tools to purchase or to procure if we know about our real needs and requirements in the field. And those are the basis for the R&D process that Lenny mentioned, but also for purchasing or procuring for off-the-shelf solutions. The process of the needs definition was started in very early stage of this project, together with the scenarios defined and presented by Jakub just recently. And then we had, just before Christmas, it was a nice period, some really open, wishful thinking discussions within the project. And just in the beginning of the new year, in 9 national workshops all over Europe with external stakeholders, to create a full list of, if we could just scratch something on the paper that would be our future solutions, how could it look like? And this ended in a first draft or first version of our requirements report that is already available online. Now we're in the stage of, so in March we prioritized those collected needs, because it was a like several pages long list of wishful thinking needs. And now with a prioritized list, we created a survey that has been conducted already within the project team, but now it's also published for all over Europe to provide needs even beyond the borders of this project. And so if you know some stakeholders that are involved in bases of operations or emergency shelters, please feel free to share the code so they can also provide their requirements. The code is shared outside at the reception desk of the event, and is also in the presentation, and it's also online on our web page. And the results will be delivered in July, when they are available, we will put them into a final requirements report together with other results that will be given by other events, such as exercise participations, and the final requirements report. I cannot offer today, but we will offer together with our reporting in the project in the end of the project. You already heard about the participants in this project, so I want to give you the overview that we look beyond these borders. It's the emergency response organizations that participate for the needs and requirements analysis, but we also include our advisory board members, so we go beyond the scope of the emergency response organizations involved. And as already mentioned, now we are even going beyond these borders, include all countries, all member states of the European Union, and participating states of the civil protection mechanism, and different stakeholders, not only emergency response organizations, but also associations that support with sheltering, that might be not explicitly emergency response organizations. Maybe let's think about which needs have been identified so far. I told you about the wishful thinking, so it was really like just shouting out something, oh, it would be nice to have. There is the method you might know from several descriptions also from the Commission and from former projects, to wishful thinking. Wouldn't it be great if WIPKI acronym? And we just collected them. Then all partners involved also held their workshops in their countries with different stakeholders. And we had this very, very long list. I'm not going to show you because it's going to be a lot of text, and you might take the literature on your way back home on the train, on the flight, and browse through it a bit later. But you also have it online in the OMC document because the summary is published there. And already referred to, also from Björn, together with the state-of-the-art analysis, we condensed it into a prioritization matrix and followed up with some statements on, of course, for you more important metrics and values to get the tools developed. So in our ongoing surveys, still it's an ongoing process to remind you, we found out that there are, of course, some very important metrics like commonly agreed 120 kilowatt hours, or something like a reference for production or generation of electricity over a period of 24 hours. We have to think about noise levels, not only for our guests we might host in shelters, but of course also for our staff taking their time to rest in basis of operations. Weight I already mentioned, and also Jakob mentioned that logistics is an aspect, so we have to think about the weight of systems, so they can be carried also by a team or a person, a set or group of persons. The size also related to weight, but also for logistics on the transportation, so can it go on a plane, airport, cargo airplane, or standard airplane, and of course the speed, and also the time period, so how much time will it take to set it up, to get it up and running, because we have immediate actions, and how long is it going to run without any further support. Of course, those systems are not only standalone, so they should operate standalone in generation and in storage, but they will be somehow connected to other tools that might need the energy that is there. So we do need interlocks, we do need a certain set of connectors, and of course also standardized output sockets, and you know about the standards like type F sockets. We thought about having at least a set of 4. Jakob also mentioned health and safety. It's not only that we are providing health services as emergency responders. Of course, we also have to think about health and safety for our staff members and volunteers. So there have to be some automatic shutdowns of the system if it's not operating correctly, but still providing some backup solutions. And we do need some kind of control, remote control and on-site control. And of course, it would be super nice, being a very evolved community of tool providers, to have some smart management tools for the team on site. And electricity and transportation are always somehow connected to standards. We thought about some IP protocols that might be applied for the requirements. And of course, to also guarantee the safety and health issues, we need some kind of manuals and trainings. And here in our requirements, you will see soon, we also differentiate between volunteers or staff members that have no background with electricity, and also those who might have a background. So there is difference in the time for training to apply tools that will be available for them on site. And the life cycle already mentioned, 10 years for a lot of aspects is somehow a metric that is on our minds for particular life cycle issues. I told you about the surveys that are ongoing. We have some preliminary results. I have to stress here that this is preliminary. They might be subject to change. It's some statements I provide, and it's that are statements that are mainly like agreed on, or kind of have a more common ranking so far. For example, that the system generates electrical energy from renewable or renewable-based sources, like solar, wind, bio-based, hybrid combination, but not exclusively. We are open to, we just give the requirement, so we are open to any solution that might meet our overall objective of the project. And those have to operate in the proximity of the base of operation and emergency shelter that Jakob presented with his scenario presentation before. We need, and I already mentioned it, a system that the system produce kind of minimum of 120 kilowatt hours of usable electricity, and that's within 24 hours of operation time. The system should at least give 20 kilowatt hours of usable electrical energy storage, and this is measured as net energy available for consumption after internal conversion losses. We already talked about the smart integrated energy management and the distribution, so this is dealt with and coordinated in real time and ensuring an optimized operation according to the the varying energy demands, so being remotely controlled and enable monitoring. The system power converters like DC-DC, AC-DC units always should operate in a way that they maximize the energy efficiency, and this with an average conversion efficiency of at least 92%. And when we talk about the outputs and the distribution of the energy, it should be able to provide it with 230 volt, but also 400 volt, and maintaining a voltage within plus minus 5% of nominal values within the with a given frequency stability. The system has to have a nominal output of 10 kilowatt, and that can be delivered within 24 hours for 7 days. And the system that we are aiming for should deliver sufficient electrical power for the base of operations. And you're for sure wondering, so what kind of amount are we talking about with base of operations? And we agreed on having different approaches for this minimum unit, but to have something like 15 persons, like 15% of staff within base of operation, or 15 persons within an emergency shelter to be covered in this demand. And why is there a difference also in the scenario building? Maybe I can tell you the difference is, of course, staff members will be out and operating in the field and might come back to recharge personally, physically, mentally, but also for electricity and to like have hygiene aspects. And if you shelter persons, they most likely will be around 24/7. So it's another level of peaks and demand during the daytime. The system can deliver, in our point of view, 30% of its nominal output. You remember we talked about the nominal output of 10 kilowatt before, and for at least 1 hour. And this means we aim for 30 kilowatt hours. So the triple amount would be 30 kilowatt. Coming to some more examples, the energy conversion supports the use of at least one commercially available fuel, including but not limited to bio-based fuels, hydrogen, methanol, or sustainable produced synthetic fuels. I know there are a lot of questions already on your mind. I'm going to be finished soon, and then you will have the opportunity to discuss with our panel on the questions and answers. And again, I remind these are statements taken from an ongoing survey process, so it's preliminary. It might be subject to change, and you will find the final results in the final report. Maybe just going back to efficiency, it's at least a minimum energy conversion efficiency of 50%. We want the system components to be delivered on a U pallet. There are still discussions on the weight load, but you know the measures and the size of an EU pallet, so it has to be kind of standardized for transportation. And we already talked about being also carryable, so 4 persons should be able to carry the subcomponent or the weight load or the tool stored on a pallet. The system should also operate in adverse conditions, Jakob mentioned before, and so we have to think about temperature ranges. And our current approach aims for -40 to up to 80 degrees in Celsius, and to operate up to a level of 4,500 meters above sea level. And of course, given the strong winds events in Europe rising, also up to 120 kilometer per hour without the structural integrity or stability lost. The system has a minimum operational lifespan, and I already mentioned we are dealing with more or less 10 years under the typical deployment conditions we have just been describing. Of course, it will not always be 80 degrees plus and always 4,500 meters above sea level, but something like an average through that. And the system also needs to have a continuous operation period of 24/7 for at least 10 consecutive days. Why 10 days? We have different time levels in our module descriptions on how long we are operating systems, but this is kind of an agreement or democratic decision to take 10 days at the moment. And to conclude the excerpt of this preliminary results, again back to training, because some staff members will have to apply and deploy the tools on the ground. Non-specialized personnel with no prior background needs to be trained within 30 minutes and also have some visual guidelines and manuals to follow up. So how are we going to proceed to fully charge our requirements reports? Currently there is ongoing the survey I already mentioned, again the QR code, happy to share. We are looking for a lot of answers, so we also rely on you. We will evaluate the survey together with other requirements and needs results from other sources, and everything will be published finally in the end of the project in September, together with the potential decisions, outcomes from the state-of-the-art analysis, and also from the open market consultation for potential pre-procurement in the end. So one more reminder, there is already a functional requirements report. You already know an excerpt from this, from the open market consultation document, and there's also the survey ongoing. Please, once again, a reminder, feel free to share it, that emergency response organizations and shelter providers are going to fill it, so we have a very broad approach in the requirements report in the end. And with this, I hand over to my colleague Danai from KEMEA for the further moderation. Thank you.
Hello. Hello from me too. Thank you for being here. We're glad we have this opportunity for exchange, and we aim to maximize it now, actually. So after the presentations, I hope that you have a better understanding and a better idea of what we aim to develop, actually, and for the interest of our emergency organizations. We would like to highlight that although we aim to the need, we aim to develop and deliver something that is for the interest of the emergency response, in particular for base operations and emergency shelters. Nevertheless, we would like that this system has the possibility, and I think that you are mostly interested in that, to be able to be used for other purposes, for other emergency, either for other emergency operations, but also for possibly for more day life situations by these organizations or any other. Of course, the needs and requirements are collected by these organizations, but we want to think a bit broader. So just quickly, we will start this question and answers question with our panelists and from you and the online participants. just quickly to summarize again our basic functional requirements that are already included in the OMC scope document that you have received, and you might find also in printed version here. So we aim to develop a system for renewable energy generation and storage for small units, for emergency shelters and base of operations. But let's think beyond that as well. The system, we want to generate at least 120 kilowatt hours per day, and to have the possibility for storage of 20 kilowatt hours of energy. We want a power output of at least 10 kilowatt, and to be durable with long lifespan, to have a possibility of a service island mode, so that is it works as an independent system. We want an efficient and an independent operation for quick deployment, and to be able to support multiple energy sources. That's why we may want to consider a hybrid system. So this is for this could be interesting for the matchmaking session. As said, we want a modular system to be expandable at least 5 times up the minimum energy, and it would be ideal to have a modular possibility for modular storage. We want it to be compatible with the standard equipment that exists for so far, for a possibility of integration with larger setups. We want it, of course, to be resistant at water, dust, to have a design to be transported and to be operational in harsh environmental conditions, and to have a long operational periods with minimum support and maintenance. Having said that, we want a plug-and-play design to be simple for setting up, not necessarily by experts. We want a minimum minimum need for repair and maintenance. We want it to be, of course, safe and secure in operation. We give high importance to low noise levels because this is one. Apart from emissions, this is one of the drawbacks of current conventional diesel generators. Well, we also ideally want to be air transport ready with no restrictions, and I understand that this might be one of the challenges, especially for storage systems, but we'd be glad to discuss this today. And we want to be transportable by maximum 4 people, so that there is this flexibility for quick deployment and startup, and to be compatible with standardized pallets exactly for this transportation purposes. And for sustainability, as said, we would like to be able to be used for beyond disasters to have long operational periods with minimum support and maintenance. More details on the requirements you can find the OMC scope document. As Sandra presented, we already have some more specific technical requirements that came from the internally from the consortium, from the several emergency organizations we already have, but we try to validate and to get more validate those and get more input by external organizations, and by the end of September we plan to have this finalized. So I will keep this on the screen, and we would like to start the discussion with you. Please, I invite you to share with us your questions. By the way, here is the Slido. If you want to type your question for any reason, or for our online participants, you may type your question in the chat. We consult the chat, and of course, you are more than welcome to express orally your questions. Yes, please. No. Don't.
Thank you. One of the previous slides was the weight mentioned of 1500 kilos for the set. It's now 100 kilo per person or 100 kilo in total.
No, in total, if I'm not mistaken.
On the previous slide it was mentioned it should be pellet size and 1500 kilos, or did I misunderstood that?
Is it on? No? Okay. So the idea was, of course, if we're talking about an entire system, we were thinking about, okay, what are the standards for EU pellet? And I think 1.5 tons was the standardized value of pellets, the maximum weight. But of course, you have the issue with transportation, especially if we're talking about the earthquake scenario, there's a lot of rubble, or also, for example, with quick deployment with an aircraft, and there's no forklift at the airport, that actually the emergency response practitioners, that they have to disembark by themselves and their equipment. And this brings, of course, some certain limitations. The idea was that the container systems can be divided in subcomponents that will have a maximum, I think, about what was it? About 150 kilos. So 4 people can carry it. The individual components. That was the idea.
Okay, so you should then have a possibility to break down the system in different components.
Yeah.
Every component boxed in a system what has a weight of 100 or 150 kilos.
Yeah.
Okay.
To be able to be carried out by people and do not need machinery.
Yeah, just additional comments to this. So sometimes it could be situation that we have to carry it to be able to work. So basically one part is how we will transport it, but then, okay, in the end of the day, we have to carry it to the place because the heavy machines are not able to go there. So basically that was the idea that yes, if we can this 1.5 tons divide it, then we have to think that we are always working on the team. There is no one-man show or woman show. So we have always the teammates and we can carry together. But of course, that has also legal and even our human limitations, what we can carry actually. So that was basically between 100 and 150 kilo to be able to transport.
Okay.
Before proceeding, just quickly, I didn't mention Benjamin Harting, that is also among our panelists, is from the International Department of THW and has quite a lot of operational experience, and so he can help us out. Okay, yes, please, let's start there.
Hi guys, should I start or should we wait for the guy typing?
No, please, go
Okay. Thank you. My name is Christian from LEAP in Germany. I really love the approach to this project. This is what I would like to start with. I have one question. I can understand a lot of your technical requests, and I will of course also be able to answer a lot of them. But from our experience for electrification projects and other applications, we found that looking on the consumer side is also very important, because usually we waste a lot of energy there, and the solution we create on the energy storage and energy creation can be way smaller, and it's way easier to develop one if you also analyze what you can save on the load on the consumers. And I was wondering if this has been part of your project or is part of your project, because the numbers, you did not throw dice to come up with the numbers you have here.
So in the beginning, we also talked a lot about this, because of course they're living. There are different types of standards in these camps regarding the different organizations. I remember that we talked with some French colleagues that said, okay, we don't need warm water, we can jump just into a cold river and it's fine, and similar examples. So this varies a lot, and also I think. This is a really important aspect that you're talking about, but it would require also a lot of further work to look at the consumption. I think also in the beginning we based our first inputs also on a dissertation thesis that was looking exactly how you can reduce consumption by, for example, taking better sleeping bags and so on. And based on these values, we derived also the values that were previously presented. So this is something, the values that were presented over here is something that we could more or less agree upon so far. So it's a really important aspect, but it wasn't so much part of the project.
And if I may, I guess they represent also well, the types of services that are included in the UCPM modules. Correct me, Jakub, if I'm not mistaken. Yeah.
Yeah, basically we have some, it's very good. So we know and we are expecting to also that we will have to think about that we have to change our behaviors a little bit. Yeah. So as a very good, the Bjorn said, so okay, perhaps we will bring the better sleeping bags, which could decrease the heating over the night, for example. And of course, working 24/7, which is usually the teams, especially in the emergency crisis, they work, you have some peaks. So for example, the kitchen is not working over the night because the kitchen will be preparing everything during the day, for example. So you don't have like constant consuming full energy. We use some of your already products, and we know that when we started, there is no possibility to put it lower, for example. So yeah, there are times when we don't need that much energy, but the generator has to run. And we have a lot of consumption and wasting of consumption. Yeah, so basically we know, and that is what was also written there, the smart management. Yeah, so perhaps to look at app, monitor, whatever. Yeah, to see, okay, now we have quiet time, the people are outside, not working, or the people have some activities they don't need to charge every phones and monitors and whatever, so we don't need to produce that much energy, so let's keep it down and cool it down and not waste energy. So yes, definitely we are prepared for that, but we are not expert in that. So somebody has to come and say, yes, let's think green, but that means you perhaps should think like that a little bit, then we can find common way to the goal which we are aiming to. So basically, as we are ready, we thought, but we were not able to define that. And also, Bjorn said, when we started actually, when even we were building our module, we just counted how much energy approximately we need, and then we bought two 110 kilowatts generators because of. And then when we had discussions with my colleagues from fire service, well, there is no time to do it. And even when we were on the mission, there was no time to have somebody or 2-3 firefighters going and measure everything. So we were even not able to have our own answer for our own questions, how much energy we produce needs, and you know, so we found this gap. And this project is really perfect. It's changing our minds within the EU CPM mechanism and ourselves. Okay, we have to think not only we wish something here, but okay, you have to even change your behavior. So definitely, yes.
And if I may, from our discussions and studies earlier, I've understood that there are different requirements for emergency shelters, of course, for base of operations, or different consumption, different service, and for humanitarian camps. So these are quite different requirements also for in terms of consumption, like per person. So you may raise your hand like freely. We don't judge for the question, or please type again. I promise not to delete it.
All right. Nice to meet you all. Paul Galema, Volta Energies. One of the questions which came to mind for me is that you're requesting quite a specific transportability. Is that something you have at this moment as well, with your high emission solution, I would say?
Hi. So if I understand... I think we have a flooding, and so some sort of emergency response needed. If I understood you correctly, you meant what generators and other producing equipment we already have in operation.
Yeah, and does it have the same transportability as you're requesting at this moment?
Yes. So first of all, I think it's very diverse, since we are a bunch of very diverse requesting agencies. If I may answer that from my perspective as THW, we have diesel generators in our stock, which is 6 kVA diesel generators. They are sort of small building blocks we can carry to our base of operations, and in case we also provide emergency shelters, we can also bring those. A very important aspect of those small generators is that we also use those not only for our basis of operations, but also for the operations itself. So for international emergency response, there is not only the base, but if you imagine you have the earthquake scenario or the flooding scenario, you have to operate pumps, you have to operate maybe equipment to work on those destructions and so on. And those are hydraulic equipment, electrical equipment, lighting and so on. And for those direct operations at the sites, we use the same generators. And this is also maybe a point where we derive those requirements from, since we're not really focusing on exchanging or using other generators for those sites, but this is definitely an aspect we have in mind, and since humans are very conservative in their thinking, we had those generators in mind by setting up the requirements.
And fuel supply is currently done just by jerry cans, or?
Yes, so fuel supply is actually done very easily. We purchase that and procure at the site. So if we have the scenario in Central Europe in mind, we can just purchase it at the petrol station, fuel station. If we think about the scenario in the Himalayas, we purchase it where it is possible and whatever quality it is possible, and that is the rather rugged requirement we have for those fueling.
And then maybe directly a follow-up question from my side. Is there a limit to the amount of building blocks you want to carry with the 4 people, I would say?
With those 4 people, I would say it's definitely the weight issue, and for the entire logistics, it is the issue of transportation by air. It is the question, how large is the aircraft? Can we just transport everything in one aircraft, commercial flights, cargo flights? There might be different aspects, and there's also the aspect of on-site transportation. Let it be by cars, vehicles, sometimes on foot. We even had the issue that we had to transport generators by canoe. It's a very rare case, and I think we should not really focus on that, but it can happen. We have it now in the requirements, but I would say this is not the key requirement. But transport by air, transport on-site, vehicles, cars, 4-wheel drives, whatever, this is really, I think, the aspect we should think about.
Thank you.
If I may add something to this, for example, we have 10 kilowatts and 45, which, you know, it's the products of some of you. It's perfect to use on the road, to put on the trailer, but if we go on the mission, we have to ask, for example, the military planes to carry it. Because the commercial planes are not able to carry this specific cargo, and you know there are aviation rules for that. So we are sometimes wasting a lot of money to buying the product somewhere nearby to be able to carry it. We are also then, you know, a lot of things we are leaving there because they're very expensive to bring it back. So if we go to the ecology, so we could use it once more, or it could be happening to something as a national emergency, but because of that, we don't have it. Then we have to do public procurement process, or we have to wait for some of the suppliers to build it again for us. And so it's really, really tough gray zone, I think, for us to think what we will bring. Then we are trying to use the term host nation support. For those of you who knows that, it's like if the international team is coming, we will say, well, we can do whatever you need from us in the scope of our competences, but we will need some power from you because we're not able to bring, for example, power generator. So, and then we are sharing between us as international modules, because we are trying to work at the same SOPs or standard operating procedures, so we know each other a little bit. We try to operate almost the same level to be able to work together and share some devices and stuff what we have, because it's really very dangerous to bring something to some countries. It is very expensive and so on and so on. So this is something what we wish to have, something we can split and we can transport much easier. I don't know if that's possible. It's really up to you guys. Thank you.
Thanks, Iku.
Yeah.
Yeah.
Hi, Tor Norby, MSB. We have to think about a couple of things. I mean, it's a difference between an earthquake, a flooding, and a wood fire, for example. I mean, if you have a flooding and a wood fire, you can actually go by car, by trucks. But if it's an earthquake, then the problem is. And the important is the 2 to 3 first weeks for the first response teams who coming in. They have to carry the stuff. After these 3 weeks, I mean, normally there's some kind of airport open up for international people coming in and giving a hand. So what we're talking about is actually the first 2 or 3 weeks for earthquake. And for 4 people to carry 100 kilos, I mean, it's just to walk a couple of times. Thank you.
Thank you.
Should I go now? Okay. Hello. Good afternoon, everyone. I'm Filippo Giacinti from the European Commission, Unit F2 of DG Home, which is the unit managing Horizon Europe Cluster 3 calls. So this is not, of course, a project review meeting, so I'm not here to challenge you. On the contrary, I'm here to understand and to learn from you, because I think it's very important for the Commission to understand which are the main challenges in order to improve future programming. So my question is rather a procedural question, I would say. So I understood from one of the presentation that the process for collecting requirements will be implemented until July, if I'm not wrong. So it's still ongoing. And that what you have now are preliminary results. So my question would be, in case at the end of the collection process, you receive different and contradictory requirements from the end user organizations involved in your project, which kind of approach would you adopt? Would you rather still try to make a synthesis between these different and potentially contradictory requirements, or would you rather look for different solutions that can cover these different requirements? Thank you.
So I think I can reply to some degree. So and later I will pass to Filomena. So of course there are also different interests and different use cases where it makes more sense to have different types of solutions. So we also inside the project and the consortia we encountered issues like okay, we want a large container system, but others wanted a rather more portable solution. And then, of course, the question is, what is the goal of the project? Do we want to define the requirements for a solution that for several potential solutions and specific, I would say, requirement waves? and in the end, we decided to go for the I would say rather smaller solution, because it's something that every organization still needs and that is relevant, especially for fast deployment. Also for if you want to build an large emergency shelter, in the beginning you need a basis of operations, for example, to set up the emergency shelter. So you will need the small system for rapid deployment and construction. So this was the point that we could all agree upon, and this is why we moved towards this direction. And we also had the tendency that this is required by all the emergency response organizations, and honestly, I don't expect to have large deviations also from the externals in the current survey. If Filomena or someone else wants to add something.
Yeah, I just want to add to this that this is why we give so much attention to the modularity, because this is a way to find a compromise between the base of operations and big emergency shelters. But as Bjorn said, we try to keep it a bit low, the number of persons. But procedural wise, I guess our legal advisors can help us more. Yeah.
Thank you. If may start first, and then of course I will give the floor to Filomena. Of course, synthesis and modularity are important aspects of our work and during this work, but we need to clarify the most, let's say, important aspect, which is that during the CSA we of course decide on a list of requirements which can be of course further redefined once we will have the PCP project. At that point, we will of course bring together all buyers group, the buyers group, the members of the buyers group, who will decide definitely this time for a list of requirements. And this list of requirements will be of course part of the tender documents, and will be of course part of the of what is actually expected from suppliers. So during the CSA, of course, synthesis and modularity are the basis of our decisions. Thank you.
Filomena, you want to add something?
Well, is this working? Yes, thank you. Perhaps I didn't understand the question. I thought you were asking something about a kind of methodology, or what would be done if there were contradictions between the members of the buyers group. That was what I understand. And of course, all the work that is done in CSA has something in mind. It's finding the common grounds between all members of the future buyers group. So, of course, each entity from different countries, from different cultures, from different ways of doing things, they would be expected to ask for sometimes different solutions. But what is good in a CSA, and what is also the purpose in the CSA, is to find the common ground. And that common ground is what goes for the tender documents. So that was what I understood. I hope I didn't deviate from the question. Thank you. Well, I'm Filomena.
Thank you. Yes, of course. We will proceed with the slider questions.
The first one that disappeared already, but there was a question I remember what it was they asked. Are we open for alternative setups if they fit our needs? So the question was, do we have any constraints? If they say we have certain requirements, do we indicate how this need should be fulfilled?
By the way, I don't think we have a concrete setup. So I guess we are open to this, provided that it meets the rest of the requirements that we have described. But Eleni, you wanted to add something?
Yes, and this is of course a very important aspect and characteristic of the PCP. We present our need, our expectations, a list of requirements, but of course any approach, any idea is more than welcomed. And this is why, and this is the reason why a PCP starts, besides of course phase 0 with the open market consultation, starts from phase 1 when we expect from suppliers to design the solution. So any approach, of course, is more than welcome. Of course, under the condition that it addresses our needs, expectations, and of course the minimum requirements set.
Okay, one question that I remember is if there is a specific TRL, technical readiness level. I think the answer is no. Am I right? Yes.
Ideally, at the end of the PCP, since it's actually what we are procuring is R&D, ideally the solution should reach TRL 7 to 9.
I remember before you will post it, I remember there was a question about the outage 100, 110 and stuff like that. So, well, I think Björn can answer it, or Benjamin even better than I.
Yes, so I'm just speaking now for THW International. No, so we bring our equipment, and these are generally items purchased in Germany. So they have our frequencies and requirements. So we do not, from our perspective, consider other frequencies in our operations. Yeah, and if we purchase,
in the US.
Exactly. So if we purchase equipment somewhere else for immediate needs, then we also purchase perhaps some sort of switch or whatever, and we do not really consider something else. Pretty simple. But other entities may answer this differently. This is also very...
Okay. Assuming that the fuel selected should be the most common and easiest, fastest one available worldwide, in your study up to now, did you find some effective alternative to diesel fuel as primary mover of a system like this?
Yeah, I think that is a really complicated issue generally with regards to renewables. Also if you look at other storage systems that are not batteries, so of course, if you have the infrastructure in place, it would be perfect, to get access to local fuel or to the local grid, for example. But of course, in several of these scenarios that we also depicted, infrastructure is destroyed. And of course, if we're talking about emerging technologies that could be relevant, like methanol, like hydrogen as a fuel, as a storage system, then of course you cannot buy it locally at a gas station or something so far. So of course we have considered that, and so we also at some points considered if we could do electrolysis at site, but I think that would be also quite complicated. If the infrastructure is there in 10 years, then maybe we could consider some of these alternative fuels, where we are also not limiting ourselves. So if you have if you are an innovator or a supplier that can create a sustainable fuel at site, that would be perfect for us, of course. But of course. If the infrastructure is not there, it's a large issue, and the current advantage also for emergency response organization is that diesel is available everywhere in the world, and this.
Thank you. The next question is, how do you envision collaboration between SMEs, large enterprises, and research institutions throughout the procurement process.
It may start, okay. Thank you. Okay, thank you. So this is a very good question. Of course, it is related to the future. It's related to our future plans for the PCP. So once we will launch the PCP, specific eligibility, selection, exclusion, and award on-off criteria will be set. Within the eligibility criteria, there will be also foreseen the possibility for tenderers either to solely submit a tender or to jointly submit a tender with other organizations or with other suppliers, technology providers, research institutes or SMEs or large companies in order to actually jointly address our needs, expectations, and requirements. Of course, as in other, in every the procurement, even in traditional procurement, the possibility also will be there will be also a possibility for subcontracting. So to directly reply to the question, we will of course offer the possibility for jointly tenders and also the possibility for a consortium that will also include subcontractors for specific tasks. Thank you.
Okay. Is there a volume expectation defined on the quantity of systems needed?
Refer to the pallet.
So we are not sure how that question is, if it's production-wise or like how is that meant?
This is no, I thought the volume, like a volume.
Like how big it will be, or the space, it could be, or the space. Yeah, so the volume, yeah, tough to answer.
Yeah, the volume is
the volume. The volume we spoke. It was about pallet size, that we can really use it and easily transport it in different vehicles, crafts, and stuff. I don't know if that was the question. Explain on quantity of the system. Okay. Perhaps it was meant. Yes, I think, and even. We are expecting that it will be combination of different systems. So it will be not just one system. Yeah, if that was the question. So definitely it could be combination of two technologies together. It doesn't have to be just one technology. I don't know, hydrogen. That's it. No, it could be combination, and we think it will be even the combination perhaps at the end of the day. So if that was the question.
Yeah, I think it's more on the production and the selling. But we won't sell, right? We want. I mean, no, you may do whatever. I mean, within the project, yes. Yes, there is one question. Anyways, I want to highlight that we some of the questions that are more generalized will be included in the Q&A document that you can find online in our website. So we will answer there the questions that are more generic. We would like. Shall we break now? Sorry, I don't see the time. Yeah. Okay, so we can start now with the presentations of. The suppliers. So yeah, it's going to be well, just be patient. I think we will have some interesting presentations. We start with Hybridale company, Stefan Ingarde and Hampus Karlsson, right? Are going to present a hybrid system for power generation and batteries.
Is this one on? Yeah? You hear us?
Yes.
Yes, good.
You can start, thanks.
Thank you. Okay, so we are Hybridale and from Sweden. My name is Hampus Karlsson.
My name is Stefan Ingårde.
We CEO founders for this company. Sure. So, We provide flexible services in tailor-made solutions for hybrid backup power system designed to meet the specific needs of clients across diverse sectors. The image to the right is a unit that we delivered in Ethiopia to a project for MSB. Modular based. And that one showed that 98% of electric consumption comes from renewable and saves 10 full trucks of diesel fuel per year. Så kör vi nästa. Okay. Yeah, yeah. Okay, this one too. Project. The image to the left illustrates a simplified system intended for rapid response operation, which can be mobilized within an hour. It's now on mission in Chad for testing and evaluation. The image to the right depicts the requested system, which has higher capacity and requires more on-site personnel. The mobilization time is approximately 6 hours, and the system is intended for more semi-permanent deployment over extended periods. Då är det på teknisk specifikation. Yes. And the technical. The system consists of renewable energy sources, solar panels and wind turbines integrated into a three-phase system where all components operate synchronized with a small optimized generator. The total deployment area required is 25 by 12 meters, and that's like the solar array, so that's quite a lot of space if you need solar modules.
Like the request.
Yeah, yeah, like you requested. Vart är vi nu? Vi är på technical. Det är den, då kan vi köra nästa. Transport. When the system is packed down, all components can be transported in stackable, fully waterproof boxes. The boxes are designed to be handled by a team of 4 people. The challenge with this size of system is transportations. So it will be approximately 12 boxes, like for displayed here, for the solution, and the space-consuming solar array when mounted. Next. Overview and monitoring. All installations with internet access can be monitored and controlled remotely via the online VRM system, where all support and operational status can be managed. With this connectivity, we are able to manage generator start-stop function, access reports detailing the system CO2 savings. Och sen är vi på system overview key. Här är nästa. The system offers global availability of spare parts and is built to a robust standard, ensuring long-term operation with minimal maintenance and requirements. Did we fit the time? Yeah. So that's. Thank you.
Thank you both. Then we can proceed with Stefan Tilch from Volta Energy.
Yes,
with a
thanks.
mobile solution with solar panels for power generation.
Hi everyone. My name is, I will try to continue, here. My name is Stefan from Volta Energy. And before I tell you everything about our great solution, I wanted to ask you a question. Does anyone know how many diesel generators are used in Europe? Anyone wants to make a guess? Okay, I will help you. It are 250,000 generators just in Europe. And that's exactly what our 2 founders wanted to change. So they created a mission to exchange all existing diesel generators by a more reliable and a more cleaner and independent solution. This is how it looks. So we have a trailer-based system, and I will later show you an overview of all our models. But it's a trailer-based system existing of three components, which is solar, a battery storage, and a backup generator. It's really easy to set up. It just takes 2 minutes, and it's available with different backups, whatever is available on location. And in total, you can save up to 90% on CO2 with the combination of all components. We can deliver from 2 to 120 kVA, and as you can see below, those are our different backup systems. So we have experience with providing them with HVO 100, which is a biodiesel, and with methanol, but also with hydrogen and propane. So as you can see, it's quite easy to change the backup system, and the rest of the system stays the same. And to give you an idea how easy it is to set it up, I've brought a video. That's me. So even I can do it, and I'm not a technician. But to see what the actual effect is on site is that I've brought different backup systems, and I've tried to compare it with a diesel generator. This one is 24/7 use, so delivering 24/7 continuous power. And what we can see that there is a huge difference, and this is due to two effects. First of all, because of the reduced running hours of the actual generator, because primarily we try to gain the energy out of the sun, and secondary the battery, and after that the backup generator starts. And if you look at the other below diesel, methanol is of course way more, way better and way greener than HVO 100 is. And if you use green hydrogen, it's even CO2 neutral. What does it mean in costs? So kind of the same image except with the hydrogen, because hydrogen is quite expensive. But as you can see, if you're just looking at the fuel costs, it's also a huge cost difference compared to a diesel generator. And this is just the fuel and not the time of people refueling it, etc. So, summarized, at the moment we have more than 400 systems, and 90% of them are rented out. So we collect a lot of data, and we can and with that data we can also improve our product. And what we have learned is over the last couple of 3 years, we created an uptime of 99%. And we improved lifetime costs, and this software also gives us the opportunity, not needing to go on site to do maintenance or finding the fault in the system when it's not running. So even if it's just 1% of the time not running, for example, 80% of the faults can be solved remotely. And this also gives you a good fleet management, and you have actual data that you can use to see your savings and gain the full and live control of the units. Thank you so much.
Thank you, Stefan. It seems, well, I have some questions in the future for you. No. Yeah, next is, well, Andres from Andres Elektrogerätebau. This is Andre van Kerven and Anastasios Meonidis, or who are you?
I'm the English guy, so
English okay, you're Anastasios Meonidis.
So, yeah, good evening to you all. I would like to introduce you the company Andres today, but yeah. Okay, sorry. But first of all, many thanks to the organizers for the invitation and the opportunity to represent the company. Thank you. So, no, the direction. Oh, where is it? No, here we are. So, okay. So, yeah, first a few words about the company. Andres, we are a small, medium-sized, let's say, company located in the southern part of Germany. You see the figures with around 100 employees and more or less 65 million euros in sales. Our company is mainly working in two business fields. One business field is what we say industrial applications, but this is not the case of today, not the topic of today. And the second field is products for civil protection, disaster relief, firefighting, etc. So, since more or less the 70s, our company specialized in producing power supply systems. Probably most of you know such kind of products, generators running by combustion engines, which is still one of our main products. But of course, all we know that things are changing, yeah, and especially topic of the day, climate change, climate awareness, sustainability. So since several years, we have also been involved in the research and development of battery storage systems, storage solutions for energy. And on the right side, you see the battery storage system. It's already existing, field-proven product. Battery storage system with 30 kilowatt hours, which can run completely independently, but also in a combination with our power sources, especially with generators. And this combination, the hybrid solution, is more or less what is currently running most of the time. So it's a transitory period, generator plus battery storage systems. Probably in the future, it might be more battery storage, we'll see. And some key figures for this product. It's the intention was to have a very small, compact design, which more or less fits on a standard Euro pallet with 120 by 80 centimeters and weighs less than 1,000 kilograms. It's very, not easy, but let's say simple to transport with different kind of carriers. It has a very clean design, so it's very easy to be used, and the setup time is very short, so it's more or less, if the batteries are charged, it's a plug-and-play system. And also the training time for the staff is very short. So it can be used also from non-professional, not electrotechnically educated people. So, and it was already the end of my presentation. So, if you have any questions, you know where to find us.
Yeah, we have the session right after. Thanks a lot, Anastasius. So we may proceed with Marcel Kieser from SFC Energy for the methanol fuel cell and hydrogen fuel cell system.
Okay, hello, my name is Marcel Kieser and I'm from the company SFC Energy, and we are located in the south of Munich. And short facts, we are founded in 2000, and so we have nearly 25 years of fuel cell technology wisdom. We have now over 75,000 fuel cells sold and have 8 locations. Our main product is the direct methanol fuel cell on the left, the EFA Pro 2800 with 125 watts, and the second one since 2000 is the hydrogen fuel cell. And yeah, the different effect is hydrogen needs gas, the direct methanol fuel cell need liquid methanol. Our performance scale is from 40 to 200 kilowatt. So we split it direct methanol is still 1.5 or 2 kilowatt, and then after that we have hydrogen. Normally hydrogen products are in like power supply for telecommunication systems in Germany, also Denmark and other regions, and the methanol area is for video surveillance or mobile homes, and for like the crisis prevention, we made with our partner Axol a container, and in this container we have like 2.5 kilowatt direct methanol, then we have 56 kilowatt hours battery capacity and photovoltaic to get more autarky. And now a little bit more information. So for the hydrogen area, we have stationaries and mobile hydrogen generators. This would be now the mobile generator with 10 kilowatt of constant output till 28 kilowatt of peak power. And we have that system with tanks and without tanks. So when you have the tanks, you have nearly 24 hours, 10 kilowatt output power. And the rest thing would be like minus 10 degrees to plus 50 degree. The weight is a little bit higher, but yeah. The batteries in the tanks are really heavy. And the second system is now the 50 kilowatt system. It's a prototype, but we will produce it January 2026. And it can be combined with 4 of them to 200 kilowatt. And it's like liquid cooled, has 1.8 kilogram at the 1.8 tons at the moment, but it should be get lighter. Yeah, thank you.
Thank you, Marcel. Thanks. Then our next presenter is René Fischer from Waterlamp with Niklas Taya. From, yeah, they're going to present a solution for energy generation with water-based liquid. Yes, of course.
Okay, thanks.
Little preparation, sorry. One moment, please. Okay, here we go. Imagine this. There's a blackout and everything is dark. No batteries, no backup, no generators. A nightmare. Not only in crisis situations, also for 750 million people worldwide which have no access to safe electricity. At the same time, Europe alone throws away 35,000 tons of batteries each year, more and more. A huge pile of toxic waste that harms the environment. This has to change. I'm René, this is Niklas, and together with our business and technology partner Georgios, we built Waterlamp, a unique, innovative and sustainable energy on-demand source.
Yeah, Waterlamp is a function, yeah, okay. Waterlamp is our technology and our name is Energy on Demand. And our technology generates electricity using just water or any water-based liquid. No batteries, no charging, no toxic waste. You just dip it and you get directly light. And this technology works through a controlled oxidation process and is completely maintenance-free during storage. It has a long shelf life and is fully recyclable. It's perfect for disaster relief, for military uses, for outdoor adventurers, and also for remote areas. And our first product, it's an emergency flashlight, proof that our technology perfectly works. And with one activation of water, it runs up to 80 hours on a single activation, 1,500 hours in total. In this time, it saves up to 200 batteries and saves to work on in any crisis. Now we scale up. This technology is a foundation of a full product portfolio for civil protection, also for humanitarian organizations.
Yeah, disasters and blackouts are increasing, and climate change, energy insecurity, and geopolitical tensions are pushing the existing solutions to their limits. And yeah, batteries and generators are difficult to store and transport. They create hazardous waste and often fail in critical conditions. And water lamp offers a new approach. We have no dependence on power grids or batteries, and we have a maintenance-free and safe to store over decades or centuries solution which is always ready when you need it most.
And our first steps are also in progress. Our first working ready energy on demand prototype is ready, a very important step for us. And we also are in early conversations with actors from the civil protection and from the humanitarian organizations. And finally, we are here in Brussels to collaborate, to connect, and to explore how our solution can fit into real disaster situations.
Yeah, and now we are looking for pilot partners, agencies and field operators who want to test water lamp in real-life scenarios and co-develop practical use cases. Let's work together and bring energy where no infrastructure exists, because in every crisis, reliability is everything.
Thanks.
Thank you.
Who's the next?
Thank you. It's interesting you may introduce the next. Yeah, thanks a lot. The next would be Jürgen Zinneger from Axol. Is he here or? Ah, yes. We didn't have your presentation, that's why.
Yes, you have.
We do have your presentation. Okay, now we do have it.
Hello, folks. Should I switch somewhere? Yes. Okay. Might be a little bit mess up with the slides, but okay. Okay, so it works. My name is Jürgen. I'm pleased to have the chance and to be invited to talk about the technologies. Sorry, that goes by automotive settings, so I have to switch a little bit forward and backward, I think. Okay, the company is Axol, located in Germany. We are active, like you see, in military applications quite widely. We do this stuff since more than 12 years. This is the standard demand, you know, power all the time. What we do is we supply with battery systems in combination with generators, military applications. You will see a lot of pictures. What you need in core is a control unit. You need to control your inputs and your outputs, and that mainly quite easy setup with one button functionality in defense, because there is no chance to fiddle around in use. So what we do, sorry for the picture, this is the master with a switch on the folds. So you have some dark pictures at the moment because the backside is not compatible, but not the big deal. So this is a very strict developed unit for military application, 50 kilograms, 2.4 kilowatt, 2.4 kilowatt hours. One button operation serves 90% of all military applications, actually roll out in NATO for different applications set. Like you see here with HPE, the new
field command post server, and this is standard equipment. So this is widely spread. Widely spread, you see here the same application with for a medical tent made with Nolens as partner for the US Marine Corps. You need charging application in field. This is a 20-foot container charging and serving the camp with all the inputs possible: wind, solar, fuel cell, genset, even up to electrolysis in the next step to the units. This is how a container looks like. This is what already Marcel showed. This is the system we designed for the German civil protection, which nearly digests all input and serves all the output. So in that case, it's combined with a inflatable tent with all the technologies inside. So fuel cell, photovoltaics, diesel generator, and that remotely controlled. Like you know, this is a setup with 2 large tents for about 250, 300 packs you can accommodate. So, but let's go further. This is how it looks like. This is, you know, the setup for 2 tents. This is the software component coming with it. This is a larger array for data centers, which we are going for. So we're going from small units up to the large stuff. This is what we serve, and we integrate for different solutions. This was the most demanding competition last year, which we won together with our Canadian partners, and we saved for 150 packs camp about 42% of the diesel, and prepared also black water to potable, and we burned all the waste with gaining the energy back. This is the setup. This is what you see here is a new way of accommodation and power supply in military applications with different vehicles. Sorry. So this is accommodation for the troops in the night from the vehicle, serving the power. Can be collapsed to 15 centimeters, transported, and used in the next rendezvous area. This is where our systems are installed. This is the latest exercise, most demanding electrified battlefield exercise of NATO, where you see all the applications set up. And what the message over there is, it's not only one thing. Okay, this is modular, this is one brick, you can build a wall with it and you can serve everything. So it's a mix. So you need charging infrastructure in your future. This is a 3D camp. These are electrical vehicles, medical application. So your demand is fine, but I think it needs different setups. And you don't get everything in one box. So there are different use cases, and they have to be brought to field working for the staff. The staff has to be served in best way. Safety is another issue, which is addressed very strictly on military applications. So there is a lot of room for discussion. And is it possible? Yes. This is the message. It's possible. Integration is demanding, and it needs some cooperations, I'm quite sure. Like you see here, with SFC, we built most of the methanol applications as an integrator for special applications. So we are already in touch with the most organizations, so we already presented at THW sometimes. So fine. I say thank you. If there are any questions, feel free. We are integrating different technologies, even on batteries. One word for the batteries. Batteries are increasing like hell in technology at the moment. So there is a lot of surprises waiting for us on batteries. So the way forward is already to be taken into account on the solutions. This is my message to you, and I'm glad to have some questions. Thank you.
Thank you. We proceed with round 2, right? We're back. And now, yes, Fabio Boscolo will present for AVL Italy. Yeah, a suite for energy management, I guess.
Good afternoon, everyone. My name is Fabio Boscolo, and I'm honored to be here representing AVL Italy at the POWERBASE OMC event. Thank you for taking the time to join us. Today, I will describe you our AI-driven open IoT platform for energy management and optimization. Before talking you about this new product, I would like to give you some information regarding AVL Italy. We are the Italian affiliate of the AVL List Group with a headquarters in Graz, Austria. AVL Italy was founded in 1980. We are more than 350 employees. We are operating in 2 different locations. One is Torino, the other one is Reggio Emilia, where we also have a technical center where we can test engine, fuel cell, battery, whatever the customer needs. In 2024, we reached 140 million euro turnover. So let's start with Athena. Athena stands for Advanced Technologies for Energy Efficiency. Our solution basically is composed by different kind of IoT sensor, like for example energy meters that can be installed on site. But we can also monitor other aspects that are more critical for the customer, like for example water quality or also air quality. As said before, we are not just providing an IoT platform, but for engine monitoring, but also with the use of AI and also machine learning algorithm, we can support the customer in taking action based on numbers. So basically, data-driven actions. It's fully customizable. It's completely developed in AVL Italy, so we are taking care also this. But the customer can also make himself dashboard or KPI calculation, whatever it's needed. We can offer, for sure, a turnkey solution, and also we are supporting green and renewable energy. Here you can see the 3 pillars of our goal. First of all, for sure, profitability in terms of cost reduction, not only for energy cost reduction, but also with usage of predictive maintenance, we can also reduce cost. As said before, we are able to integrate different systems. For example, like said before, diesel engine, whatever it's already available can be integrated and condensed in just one single interface. Third one, sustainability. Of sure, the aim is to reduce CO2 footprint. So we are also using KPI parameters in order to reach the goal in terms of sustainability. Here you can see the 6 basic functions that we can offer. Starting with analyzing already existing data, we can take care of big data, so not just a few weeks, but also years of data in case are available. We can monitor different systems, also already existing. We can integrate other systems that are communicating with the usage of the most common protocols available right now in industries like, for example, BACnet, Modbus, Connex, OPC-UI, and also CAN. We can connect already existing system and PLC if they're available. We can visualize data through dashboard that can be customized, and we can control different systems. This is why we go beyond the simple monitoring of a system. Here you can see an example, a possible use case that can be adapted to a building management system, or for example, multiple shelter monitoring system. We can integrate already existing system, like for example, HVAC or power generator. We can also manage green and renewable engine resources like solar panel or fuel cell, hydrolyzer, or whatever. We can also monitoring HVAC system and, for example, lighting. For additional information are available at avl.com/en/avl-Athene, or you can easily reach me at fabioboscolo@avl.com.
Thank you.
Thank you. Then, next presenter is Christos Velios from from Hyposto Energy, and he's going to present the portable energy storage system. Yes, please take the microphone. Yeah.
So, good afternoon. My name is Christos Velios. I would present you the portable energy storage system from Hyposto Energy. I'm a founder and CEO of Hyposto Energy. This is a classical startup. We are located in Wiesbaden in Germany, and let me today guide you through a new benchmark technology. It's a LTO technology. It's a new cell technology of capacitors technology. We use LTO, it is lithium titanate oxide capacitor. We are using, the basic is lithium, but it's also oxidated lithium. That means we have much more advantages than other cell technologies. And in the past, at 2018, we started with the first idea, the first products. Now we have patented and certified products. We have international products in the photovoltaic, wind, hydrogen market. And today, Europe needs a reliable, safe, and long life system for the market. You see also in Europe blackouts and earthquakes and so on. And we want to show you our portable system today with Hyposto's PES. And please, don't be hard with us because we don't knew the requirements before, but I will give my best. We are led by 4 co-founders by Hyposto, and this is the projects and I want to show you. What are the technology bottleneck nowadays? Nowadays we have the current storage. Known problems is increased security risk, we have fire and explosion risk, we have short lifetimes, around 6,000 charging cycles, we have long charging times, low efficiency, that means that the energy that come in don't come completely out. Also we have high recycling and service costs. The generator bottleneck is also inefficient with low load. They have emit greenhouse gases, noise emissions, and also to get the quantity of diesel, the prices, and also the local markets are different. What we make with our technology is we have a low voltage system. We have performance 50,000 watt, 15 kilowatt. That means we have 4 times more energy possible than competitors' cells. Also, we provide or we make a suggestion with a 6 kilowatt hour product. It weighed under 100 kilos, dimensions 60 to 60 centimeters. It is a proposal. Pricing, yes, P agreed by the volume. We have no fire, no or explosion risk with the cell. Even if the cell is damaged, the cell also work underwater. We can, for our customer in Sweden, we have minus 40 degrees. By minus 40 degrees, you get 70% of the capacity out. By 0 degrees, 96% of the capacity. By plus 65 degrees, that's for the customers in like Greece or Italy possible. We have a low charging time when the energy is existing. We have a load rate from 10 C or 50 C by 2 to 10 minutes. We have lifetimes over 24 cycles by 80% DOD. That means we have a lifespan about over 30 years. We have minimal self-discharge. That means if you load once the storage, you can let it over 6 months. We have low discharge. So also, most John Deere IP65, we have certifications TÜV Süd in Germany or ESC International or a VDE from German certification. Yeah, our storage have no noises, no greenhouse emit gases. We need no diesel. We have a short setup, it's plug and play. Training is from 30 minutes for electrical non-people, 1 hour for non-electricals. We have many transport options. Also, as I know, our cell is certified for via plane. That means our cells come via plane to us, full loaded, and we use it in our storage. And also, we are scalable from 6 kilowatt hours to 1 megawatt, 10 megawatt as you want. It depends on you. Also, I have to say, by the temperature we have, they have the temperatures, operational temperature, but we have testing by plus 130 degrees with the cells. The sea meters, I think it was 4,500 meters. We don't have tested yet, but we have now a project with ESA. We make orbital testing, and we will find out. So on the next slide, it's just a proposal. How could it be, yeah, for THW? Our system is an adaptable system with other partnerships like lamps that you use or tents that you use or trailer systems that you want to use. Also different sockets, your tools that you have to use, and we are all guided via app system. Yeah, you can control it with a handy. And the things that are not possible this time is beaming or time traveling that we cannot make today. It's too expensive. And if we would be part of the 1 million euro, I will not read all about the highlights there, but if we would be part of 1 million euro, we would, or the target is to get a tier L9 product that is proven in real world conditions as the other products that we have. And yeah, that is a short summary that I told you this time also. Maybe some highlights is the peak power. I think we have 4 times more peak power than all the competitors that we know. The long life from us, portable, plug and play, easy to transport certifications. Also repair able, I think I don't have told it, recycle able up to 100%. Yes, I'm at the end of the presentation. I'm very glad to be here today, and hopefully I would be our company would be a part of this wonderful POWERBASE project, and thank you very much, and yeah, enjoy.
Thank you, Christos. Thank you. Thank you. Our next presentation will be by Matic Navodnich from TAB DD. He's going to talk about a battery-based electricity storage product.
Hello everyone, my name is Matic Navodnich. I'm coming from Slovenia, from company TAP. So we are battery experts, developers, and producers. We are located, in Slovenia. You may know where it is. If we show this to US citizens, then they have no idea. So maybe we are present on the market as a company for 60 years, 1,700 people working in our company. We are one of the main producers for lead-acid batteries, and now for 8-9 years also for lithium batteries. So this is, let's say, our main portfolio, but more and more we are investing and producing big size solutions like utility scales and others. We have one of the most advanced production line in Slovenia with 1 gigawatt-hour capacity per year. And today maybe I will go in detail with Project Hebron, which was national project for military purpose of use. Quite similar solution that we saw the proposal today. So our part was to develop and deliver the battery which is able to operate in rush conditions for military purpose of use. So there was many challenges, because when we go deep into details, the deeper we go, more demanding it is. So everything is managed with energy management system. We have two solutions. One is with diesel generator and one is battery only. So this project was executed in collaboration with Belgian company ZET, so charger producer. And I also saw that several of you are working with Victron, so we are also with real deep collaboration with Victron. Probably we're gonna be the first one and the only one who will be able to update all the data via Victron control box to the batteries and have full control and compatibility with them. So just for information. Yeah, then as I mentioned, we are also focusing big solutions. So this is one of the first air-cooled solution. Now we are developing liquid solutions for different purposes of uses. So I think that project here is really well set it up, and our contribution to this project can be following. We have 20 R&D engineers who are dedicated, specialized on the special R&D projects for the batteries. Yes, we can offer complete solution, but I think it's better that we do the part where we are the best. So this is the battery development and production. Then production capacity is quite enough for all the needs. Quality is one of the, let's say, first thing we are thinking about. So we have also strong lab for low voltage batteries, for high voltage batteries, mechanical lab, quality lab. So we have also own logistic department and service team. So if needed, within few hours, we can reach every part in the Europe with our service technicians and partners. So this was quite quick, quite short. I hope that I told you everything that needs to be told, and I'm also available later if there are some other questions. Thank you.
Thank you, Matek. Thank you, Matek. We will hopefully have some time in a while. So next presenter is Christian de Tlevsen from Leab Automotive. He will talk about a mobile energy storage solution. Yes.
Looks good. Good afternoon, ladies and gentlemen. My name is Christian. I come from a company, Leab Automotive, in northern Germany, and we are an electronics and battery company with a large catalog of solutions when it comes to storing energy and converting energy to all kinds of voltage and power levels. But for today, for our project, I have come up with a specific special prototype for the use case of the POWERBASE project that I would like to present to you, and I've simply called it a rolling solution. Who is LEAP actually? We are in northern Germany, but we are part of the Swedish micropower group. So in total, we are around 600 people caring for battery and power electronic solutions all over the globe. We have been founded in 1989, and the brand LEAP, we are around 60 people actually. We focus on mobile energy solutions for the market we call rescue and safety. In rescue and safety, we have everything in blue, white, red, and green colors, and we do a lot of solutions for this market with internal development and a number of production sites in Germany and Europe, mainly in Scandinavia. And actually, there are a lot of cars on the picture here, and emergency services vehicle are our core market actually. There are rare occasions where you find a vehicle with a blue light on top in Germany where there is no LEAP product in it. You usually don't see our products. That's why you probably have never heard of our company. But we can take our products into different housings and different applications, and we have built up a prototype in a rolling container. So, and one prototype actually exists, the one with the light pole on it, and the other one is a drawing with an actually existing battery generator on top of it that has been or is a serial product of one of our partners or one of our customers. And I would like to show you what they actually can do right at the moment. This rolling container that we have built, we can put in batteries from our make in 5 to 45 kilowatt hours. That is what we can put into this unit, and we can add different types of power electronics to have between 3 and 11 kilowatt output in this rolling containers, and depending of course on what you put into it, the size will vary from 70 kilograms to 450 kilograms, but the batteries are actually dismountable and interlockable, so you can open the side of this rolling container and take individual batteries out. Of course, it's all battery powered, so you have no operating noise and emission-free, locally emission-free, of course. We can, when we look at the requirement of modularization, we could think of something like this. That we have mobile individual boxes on those rolling containers that then have an individual setup of power electronics and batteries depending on your use cases. We could even add standard products like this battery-based generator for an, let's call it, first arrival module, so that you can just take it and go to your first site where you just need quick and reliable energy supply. And the footprint of those rolling containers always are or is a EU-sized pallet, so that you can easily store it on there. So in this rolling container, we've also put in one of our modules. I mean, we control all of the hardware and the software, so no one tells us what to do. We have one connectivity module, it's called Unity. We've put it in there, and it has two use cases. Use case one is the local control of your energy devices, so that the people working in the basis of operations and emergency shelters can look, what energy do I consume, is there an error, what should I do? And there's the small magic is it's wireless, but the wireless controller you see here, it gets the power from the battery and spans up an own individual wireless network. So this is why we don't need any external power sources. I mean, use case 2 is remote access. When you want to know what's going on or when you want to see it, then of course you need some kind of LTE modem, which is in there, but of course this needs a running active network. So, all in all, the base components in terms of power electronics and batteries are available for the use cases defined in this project, and we could start testing immediately. The prototype you saw on the pictures is available in Boostorf, and I could bring it in any place. What we don't do at LEAP or at Micropower is the generation of energy. We would need a partner for the energy generation, and of course, our main focus is power electronics and batteries, so the assembly of the complete product. We can do it, but it's not our core business. As I said, we have an R&D team available mainly in Germany, Sweden and Finland, with the production sites at the same places. Actually, in Sweden there has just been a new battery factory where a lot of solutions can be developed and built. So this is me and our suggestion to the POWERBASE project. Thank you very much.
Thank you, Christian. Thanks a lot. And our last presenter, but not least, is Pete van der Stein from Instagrid. Yep, it's your time, and it's our last presenter for the day.
So let's see. Yeah, also portable energy, right? So I brought it into the room. I was thinking, why not? Surprise, surprise, we're also a German company. I noticed that today. A lot of companies are German. We were founded by Sebastian and Andreas. They were two engineers working at Bosch. They had a brilliant idea and Bosch didn't see it. So they decided to start for themselves. We've been expanding quite a bit. Currently, I have over 200 colleagues with 35 different nationalities. And I'm representing the Dutch team. I'm managing Benelux. So, yeah, we've last year expanded to the US. We see a big demand there. And we've currently started 35 new employees there. Our financing rounds also are shown here to show that we're here and we're here to stay. Looking at our customers, our biggest market is construction. I think I'm on the safe end to say that 80% of our units sold, and that's currently 60,000 units, are in construction. And emergency services are also a big part from our customers. This is mainly comparing what are we replacing. Basically the smaller generators up to 7.5 kilowatt hours, kVH, sorry. So what are we then? What's in this small package? We have a continuous output power of 3600 watts, a storage capacity of 2.1 kilowatts, and we can supply 18,000 watts peak power, which is absolutely massive, and we have this in a unit under 20 kilos. 21 here is based on our rescue unit, which is IP67, and the one that I'm having here is our standard unit, that is IP54. When it's fully empty, you can charge it up to 2.5 hours, and you need a charging power of 1000 watts. You can dive into the secret. Probably from the other manufacturers, they can see what it is here. We work with 24 modules of 6 cells, and they have microinverters, meaning our power is continuously and it's also synchronized. So therefore, it's super stable. We also have an app. And in that app you can see fleet management basically, so you can see where your units are, the battery statistics. So for example, the temperature of the unit, how long it can run on what's currently running on it, and also the positioning, so you can see where your unit is. This is basically showing what machines that we can power. If you look, for example, at the diamond core drill, you can see that they sometimes demand up to 14,000 watts peak power to start. So therefore, that's absolutely insane. To give you an example, a core drill, you can core up to 33 holes with a diameter of 120 and 30 centimeters thick. Instagrid link, I have it displayed next doors. you can see the action, but basically what you can do there is multiply the units or triple it. You can hook up 3 units to one link, and you can hot swap them. So meaning that if you have enough Instagrid once, you will never run out of power. And I think now I broke it, but it was also the end of it.